Great. Hello there, and welcome to our presentation. My name is Trey, and I'm going to be narrating on behalf of Group 5 for our project about probability plots. So, when analyzing data, an investigator often has a sample of n values and wants to check if these values could reasonably come from a specific type of distribution, like a normal distribution. This is important because many statistical methods assume the data follows a certain distribution. If that assumption's wrong, the results might not be reliable. Also, knowing the distribution can help us better understand the process that produced the data. One useful tool for checking this assumption is a probability plot, which compares the percentiles of the sample data to the percentiles of the assumed distribution. So, like we said, a probability plot is a graphical tool that can be used to visually check whether a set of data follows a specific theoretical distribution. We start this process by sorting the sample data in ascending order, which we label as x sub 1, x sub 2, all the way up to x sub n, where n is the number of observations. For each ordered data point, we calculate its cumulative probability using the formula p sub I is equal to I minus 0.5 over n, where I is the rank in the data point. Next, we compute the theoretical quantiles by applying the inverse cumulative distribution function, also known as the inverse CDF, of the distribution we're testing. This gives us z sub I is equal to f inverse of p sub I. For example, if we want to test for normality, we use the inverse of the standard normal CDF. This is also called the phi inverse. After that, we can create the plot by placing the theoretical quantiles z sub I on the x-axis and the ordered values x sub I on the y-axis. And essentially what you're looking for is if the data points fall roughly along a straight line, it means that the data will likely follow the distribution. But if the points curve or deviate from the line, it's suggesting that the data does not match the theoretical distribution. So, some places that we see this being used in the real world include manufacturing and material science. We see this where probability plots can be used to analyze the distribution of material properties. For example, tensile strength, hardness, or density. For example, if a batch of steel rods is expected to have a normal distribution of tensile strength, a QQ plot can help engineers see if data follows that expected pattern. And if the data curves away from the straight line, this could indicate outliers, which relate to inconsistent processing or maybe structural defects. And this is useful to know because it helps determine whether a material should be reinforced, maybe switched with a different material, or whether the production method needs to be improved. So QQ plots help ensure the materials meet requirements, which is important for safety and performance. Another example of this is in finance. Probability plots are used to predict if stock returns will follow a normal distribution. This is important for investors because stock returns, or their expected returns, their risk assessments, and a knowledge of how extreme the market could increase or decrease is like it helps them determine this. And they will use QQ plots as a way to visualize any deviations that might indicate a risk of potential market crashing. Events where markets are unstable and have exponential increase or decrease are reflected on these QQ plots as deviations. And these deviations, if there are many, result in a curved line rather than a linear line on these QQ plots. And investors can interpret these models and adjust their strategies on investments to avoid potential risks. So in conclusion, probability plots, and especially QQ plots, are really useful tools for checking whether data follows a particular distribution. Um, it's good for ensuring the quality of manufactured materials or managing financial risk. They're just good for visualizing and validating assumptions about the data's behavior. And understanding this can help professionals make informed decisions, whether it's involving a production process or adjusting an investment strategy. And here's just a little slide of who contributed what to the project. But yeah, thank you for listening. And we hope this gave you a clear overview of how probability plots work. Thank you.